In this example of a mountain valley location, a fire is burning near the base of the east-facing slope. The result of increased temperature and decreased humidity is increased fire activity. The smoke will lift as the inversion breaks, and the fire will be better ventilated, allowing it to grow. The spread of the fire is affected by both the natural tendency for it to move upslope and the direction of the wind. Once the sun comes up and the wind switch direction, the fire spread will increase upslope as the upslope winds strengthen. By mid-morning, the fire has begun burning up the east-facing slope. Upslope winds act with the natural tendency of the fire to move up a slope and increase the spread of the fire. The spread rate is related to the wind speed, so as the upslope flow strengthens, the fire moves more quickly. The higher temperatures and lower relative humidity will also aid in the fire spread by preheating and drying fuels. The mid to late afternoon often sees the most active fire behavior. With the high temperatures and low relative humidities, fuels are preheated and dried. Also, the upslope and up-valley flow cause relatively fast spread up and along the slope. As the sun goes down and the upslope and up-valley winds decrease, the upslope spread of the fire will begin to slow. The cooler temperatures and higher relative humidity will reduce the fire activity as fuels react to the cooler, more moist conditions. As the downslope winds develop, the upslope fire spread will continue to decrease, and the down-valley component of the winds can cause a change in the direction of spread. However, both downslope and down-valley winds act against the natural tendency for fire to move uphill, and the fire spread in general should be distinctly slower than seen in the afternoon hours. The inversion, the region where the temperature increases with height, that forms in the valley will have the effect of decreasing fire behavior beneath it. In this area, great progress can be made in fighting the fire. Meanwhile, the portion along the slope near the top of the inversion is known as the thermal belt, where the relative humidity will continue to be lower and more active fire behavior can be observed.